Guys, coming at you with a suspenseful video about math. And this video is a part of a series of videos for geometric proofs. This video is going to cover the reflexive property. So, the goal of this series of videos is to just try to introduce the concept of geometric proofs and the specific vocabulary words that go into them one at a time. So hopefully, for my loving audience, if you guys watch all of these videos, you will have an idea of how to use all of these vocabulary words, and it'll help you in this process. Geometric proofs is a difficult process, and it takes a long time to get right because you're learning how to think differently. But respect, it is an important life skill we're talking about here. While the argument has to do with geometric shapes, it's an argument of logic. And that is a crucial skill that we need to have. Okay, let's go forward with our plan for today. We're going to talk about the definition of congruency. We're going to talk about the 5 congruency postulates for triangles. We're going to talk about the reflexive property. Then I will provide a simple geometric proof using the reflexive property to prove 2 triangles are congruent. Okay, let's get started. So first, I'm talking congruency. Congruency is a similar term to equal or equivalence. The typical difference between equivalence and congruency is that congruency is identical or exactly the same in every way, where equivalence is usually referring to a numerical value. 5 equals 5. But this triangle monster is congruent to that triangle monster, if that makes sense. So that's how we use the terms. Okay, let's look at the 5 congruency postulates. So here they are. Okay, I have side, 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 which says that I have 3 pairs of sides between the 2 triangles that are congruent. I have side, angle, side, which says I have a pair of sides and another pair of sides, or 2 pairs of sides and 2 pairs of angles congruent for each triangle. I have angle, side, angle. I have 2 pairs of angles and 1 pair of sides that are congruent for each triangle. And then I have angle, angle, side. This one has a pair of congruent angles for each triangle, but the side is what they say not included or not in between them, like this one. Then I have hypotenuse leg for the right angles. All of these are methods of proving that these triangles are the same to one another. That's the goal. Okay, now we're going to talk about the reflexive property. The reflexive property is a property that states an element or a value that is relative or equal to itself. This is an abstract concept, but when you see it in a proof, you're like, oh, that makes sense. It's a fancy word for just saying something's equal to itself. So the best example I can come up with in this picture is that flower, which is shared between both triangle monsters, right, is congruent to itself. It's equal to itself. It's a shared value that's relative to itself for both triangle monsters. Let's see if that helps. Let's see if we're clarifying this in the proof. So here is a formal geometric proof. Okay, it's a very simple, straightforward one. So let's get started with some of the protocol. The first thing we do is we are given the given, and we typically write those statements down. The reason why I can say those things is because it's given. So I could say given. Given. I knew those 2 because of that. So now let's take a look at what that's saying. Well, AD is congruent to BD. So AD is congruent to BD. That's what that says. AC is congruent to BC. AC is congruent to BC. Okay, now I'm given two sides of a triangle, and I want to prove that the triangles are congruent. So I have a choice. Looking at my postulates, let's just take a look real quick. If I have two sides, my choices now are to either use side angle side to prove the two triangles are congruent. So that's where I have a pair of sides, two pairs of sides, and a pair of angles congruent to each other that says these triangles are the same. Or I have three pairs of sides that shows that these triangles are the same. So all of these guys are out. I don't have a right triangle, and I don't have two pairs of angles. So I have to shoot for one of these two postulates to prove that these triangles are congruent. So I'm going to take a look here, and I don't see evidence of any angles available to me. But what I do see is this shared side in the middle here. And that is a reflexive side. So this is a reflexive side here. Reflexive. Okay? It's reflexive because it's shared between the two triangles, right? But it's also equal to itself, if that makes sense. It's an abstract idea that may seem obvious to some folks and not to others. So I can use that side for both triangles. And the way I'm going to do that is I'm going to say DC is congruent to, in this case, DC. I could say that. If you look up here, you'll see that I have CD and CD the same orientation, so I could really keep those letters the same orientation. So, and that's because of the reflexive property. Okay? Now comes the final part of the proof. I'm going to make a statement that says, proving that triangle ACD is congruent to triangle BCD. Well, I can do that now because I have a side here, side, and a side. Then on this triangle, I also have that side. I have a side for this one there, and a side on this side. So, hopefully this helps. So if I block this triangle off, side, side, side. Come this way, side, side, side. So, I could say the triangles are congruent because all three pairs of sides are the same. As a result, the triangles have to be the same. So, I'm going to say side, side, side. Okay? And you see my trials and tribulations of being left-handed here. Okay. So that is a basic geometric proof using the reflexive property. An introductory proof at best. This isn't meant to be all-encompassing. So for this sake, I hope you guys have found the video helpful.